scientists have developed a high-quality protective film less than 2 micrometers thick that may enable creation of electronic skin displays for blood oxygen level and e-skin heart rate sensors for athletes. The technology will enable the production of ultra-thin, ultra-flexible, high-performance wearable electronic displays and other devices, researchers said. Integrating electronic devices with the human body to enhance or restore body function for biomedical applications is the goal of researchers around the world. In particular, wearable electronics need to be thin and flexible to minimize impact where they attach to the body. However, most devices developed so far have required millimeter-scale thickness glass or plastic substrates with limited flexibility, while micrometer-scale thin flexible organic devices have not been stable enough to survive in air. The researchers at the University of Tokyo have developed an ultra-thin, ultra-flexible, protective layer and demonstrated its use by creating an air-stable, organic light-emitting diode OLED display. The group developed the protective film by alternating layers of inorganic silicon oxynitride and organic paraffin material. The protective film prevented passage of oxygen and water vapor in the air, extending device lifetimes from the few hours seen in prior research to several days. The researchers attached transparent indium tin oxide ITO electrodes to an ultra-thin substrate without damaging it, making the e-skin display possible. Using the new protective layer and ITO electrodes, the research group created polymer light-emitting diodes PLEDs and organic photodetectors OPDs. These were thin enough to be attached to the skin and flexible enough to distort and crumble in response to body movement. The PLEDs were just 3 micrometers thick and over 6 times more efficient than previously reported ultra-thin PLEDs. This reduces heat generation and power consumption, making them particularly suitable for direct attachment to the body for medical applications such as displays for blood oxygen concentration or pulse rate. The research group also combined red and green PLEDs with a photodetector to demonstrate a blood oxygen sensor. The advent of mobile phones has changed the way we communicate. While these communication tools are getting smaller and smaller, they are still discrete devices that we have to carry with us, said Takao Sumai, professor at University of Tokyo. What would the world be like if we had displays that could adhere to our bodies and even show our emotions or level of stress or unease? Sumai asked. In addition to not having to carry a device with us at all times, they might enhance the way we interact with those around us or add a whole new dimension to how we communicate, he said.